So the other day, I was flipping through a copy of PC Magazine, like an actual physical copy. Normally, I do most of my research on Google Books, but I'd found this 1997 vintage tome at the thrift store, and since it had Pentium 2s on the cover, I picked it up. And naturally, I started reading from the end, since the most interesting things are always in the ad section. That's where you find the weird one-off products, the porn BBSs, and the data brick. There's all kinds of stuff back there. What caught my eye, though, was a thing called the Cybex Auto Boot Commander. That's not what this video is about, it's just what caught my eye, because that's a real fascinating choice of name, especially for what appears to just be a KVM switch. I wondered if the auto boot part meant that it had some kind of remote platform management features, something like that, but no info was forthcoming, so I tried to dig into it a little. Web searches turned up no answers, though, so back to Google Books I went. There, I found a copy of Network World with another uninformative ad. And spoiler warning, I never did find out why it's called the Auto Boot Commander, but this is how research goes for me. I find something intriguing, it's a dead end, but it leads to something else intriguing. And sure enough, a page or two after that ad was one from a company called Netmanage, offering a whole bunch of network software. And one of the apps was an X server for Windows. This immediately leapt off the page at me because it's something I've wanted to look into for a long time, but if you're not a fairly hardcore Unix or Linux person, the significance might not land. So let's just go over what X represented in its heyday, and then I can tell you why this was a big deal to me. You probably already know that graphical computing didn't really become available to consumers until the mid-80s with the release of the Macintosh, and that it didn't really become commonplace until the Windows PC explosion of the mid-90s. There's also a good chance you know that Apple and Microsoft basically lifted the graphical user interface idea from Xerox, whose Alto computer essentially invented the GUI as we know it, but you might not know that both those companies were late to the game. The workstation market was ripping off Xerox way earlier. Now, workstations don't really exist as a concept these days, but in the 80s and 90s, the term referred to computers that were extremely expensive and powerful, but still intended for individuals. And that was a big contrast from how computing usually worked in that era. Nowadays, every business puts a PC on each user's desk, and a given company might own thousands of them. But throughout the 80s, businesses and institutions often owned just one or two computers, which were shared among all their users. Naturally, these were really, really big, so it's ironic that the most accurate term for them at the time was usually mini-computer, although we still tend to call them mainframes in retrospect. Either way, it's the same principle. You have one huge, powerful computer that runs all your software on a specialized multi-user OS like Unix. But to interact with it, each of your users gets a terminal, sometimes called a dumb terminal because they only provide input and output and can't run any software of their own. Now, terminals did evolve a bit over time. Originally, they'd been literal typewriters, but things got better. They eventually became CRT-based, and throughout the 80s and 90s, companies bought whole fleets of devices like the DEC VT420. That's the weed number. And while these varied in capabilities, they were universally limited to text. A few could do very simple, very slow graphics, but most applications were text only. That was adequate, though, for a lot of purposes. You'd be surprised what you could accomplish with just text. I mean, people wrote whole books in LaTeX with terrific results. And for a lot of basic business tasks, many companies are still happy with it. The inventory terminals at Costco to this day are PCs emulating ancient IBM 3270 terminals connected to servers emulating ancient IBM AS400 mini computers. But even by the late 70s, there were tasks that just demanded high-performance graphics. If you were doing engineering simulations, CAD, or perhaps unsurprisingly, graphic design, you kinda needed a proper video display. Fortunately, those tended to be very high-stakes tasks, so there was money to go around, and the usual solution was to issue users workstations, specialized, high-end graphical computers that usually cost over $10,000 a piece. And just a couple years into the 80s, there were at least a dozen companies making these. And boy howdy, their user interfaces looked an awful lot like Xerox's. And this approach worked well enough. Sometimes it meant a user had a machine that was larger than their whole desk, but that was a small price to pay. Well, actually, you were paying a really big price, but as long as you had the money, you could usually get what you needed to run your business. There were still problems, though. What if all that power wasn't needed in one spot all the time? What if several people needed to run big tasks simultaneously? Nobody wanted to fight over whose turn it was to be on the Xbox. That's called foreshadowing. There were also still some tasks that exceeded the abilities of any desktop or even desk-side computer, so it might not have been possible to put your users in the same room as a machine big enough and loud enough to do what they needed. Thus, the old mainframe and terminal approach was still desirable, and this kinda sucked because graphics were way harder to distribute than text. Now, I think a few different solutions were fielded for remote graphical terminals, but the one that came to dominate the industry was called X Windows, or simply X. This is the resolution of that foreshadowing, by the way. Xbox, the box that runs X. I knew you were keeping up. A product of MIT's Project Athena, X Windows ended up becoming the universal graphical interface for everything Unix-like and many things that weren't. Over the decades, it would be at times worshipped and other times reviled, but any way you slice it, it did what Nintendo didn't. Most GUIs, like Sun's SunView, real creative title there, required you to plug a monitor and peripherals directly into the system you were controlling. X, however, allowed you to run a program on one computer while displaying its interface on another connected over a local network. This allowed dozens of users to share a single machine while enjoying all the benefits of graphical computing, and it was tremendously successful. By the end of the 80s, all the mainframe and workstation vendors had adopted it, but this didn't exactly bring back the days of cheap, throwaway, dumb terminals. X was a very heavy application for its time. It demanded pretty up-to-date hardware. It was apparently so resource-hungry that the 1994 treatise The Unix Hater's Handbook subtitled an entire chapter around this complaint. So, in a lot of cases, people's terminals were actually full-fledged Unix workstations, just the lowest-end models you could buy. There were actually upsides to that approach, though, and in any case, it let you have a $5,000 pizza box at your desk instead of a $25,000 washing machine next to it, so the math worked out. And there were other equations that also figured better with X. For one thing, it provided a universal graphics API, so software could be ported to any platform without being totally rewritten, but it also allowed software from multiple incompatible systems to run in a mixed environment. That detail is very important to our topic, so let's unpack it. I've mentioned Unix a couple times. It was certainly the biggest name in big iron computing in the 80s. It was used by Sun, Hewlett-Packard, and many other companies. It got ported to so many platforms it makes Doom look as landlocked as Bloodborne. You could run it on anything from Deep Blue to a Tandy TRS-80, but it was certainly not the only operating system around. There were a number of alternatives, including some really weird things like IBM's MVS or Convergent's CTOS. But one of the biggest names was Digital Equipment Corporation's VMS. Now, I don't want to get too deep into this, but suffice to say, you don't even need to scratch the surface to know that VMS and Unix are oil and water. This is on purpose. VMS's principal architect, Dave Cutler, hated Unix and made VMS almost in spite of it. So if you attempt to use it without training, you will accomplish literally nothing. Its interface and internal structure are unlike anything you've ever seen. It has an utterly batshit command syntax and file system layout, and this almost makes it sound like I don't like VMS, but I actually do. It's amazing. I mean, it has a groupware package that looks like a library catalog and the best logo in history. So what's not to love? I'm just making the point that from a user and developer perspective, it was incomprehensible nonsense for aliens. This could have resulted in a huge schism where every office was either a Unix or a VMS house. And it did. But when all the vendors began to converge on X Windows as their common GUI, they also converged on Ethernet and TCP/IP as a common network standard. And here's what all that means. Suppose you're a very computer-centric business in 1989. The big computer in your back office might be a DEC VAX running VMS because that's the platform you bought your really heavy-duty software on 5 years earlier, so you're stuck with it. And maybe it also outperforms other platforms for the time being. For everything else, though, like desktop publishing and writing emails, your users prefer Unix, which is maybe also a little cheaper. Well, good news. You can live in both worlds, and it doesn't have to sting too bad. First, you put a low-end Unix workstation on each user's desk, say a Sun or maybe an HP 9000 series, and then if a user wants to run a Unix app, they just launch it locally and it appears on their X Windows display. But if they want to run a VMS app, rather than walking over to the VAX, they can connect to it remotely, launch the app, and then it appears on their local display mixed in with all their other windows as if it's running on the same computer. X allows an unlimited number of separate systems to share one monitor, keyboard, and mouse, and since it's a network protocol, those systems don't need to be compatible. X is X is X. This is a very neat trick, and it was incredibly important to high-end computing for about 20 years. It's also been part of Linux since the get-go, so you can still do all these things today, and while Wayland will probably soon replace it for most people, I have the feeling that X will live on in legacy app support for eternity. The future is terrifying to contemplate though, so let's stay in the past. A couple years into the 90s, PCs started getting really cheap, and Windows started getting really popular. So a lot of businesses wanted to put Windows systems on their users' desks instead of expensive, rapidly aging workstations. But they were still anchored to Unix and VMS, either because the software they depended on hadn't been ported, or because PCs hadn't achieved the same level of performance as those back-office behemoths. Thing is, if a Unix system could display a VMS app using X, then obviously Windows could do the same trick, and sure enough, a number of companies developed PC-based X servers. This is obviously a very intriguing field. We can assume these products were almost exclusively bought by businesses, and they must have been very important to the companies that used them, so one wonders how good they were, and how easy they were to use, and so on. But as is the nature of business products, anyone who had an opinion usually didn't bother writing it down because these weren't personal purchases. They were just the thing you had to use for work. So I've been curious about this market for decades, but it's always been tough to track down any of the software. For years, Google returned pretty bad results for X Windows Server for Windows, as you can imagine. And nowadays it does a bit better, but a lot of what comes up is still apps that either aren't preserved at all or that don't include any license info, rendering them unusable. So this is what I expected when I searched Internet Archive for Netmanage, but to my shock, Chameleon NFS/X popped right up. This was exciting to me for several reasons. For one thing, it appeared to be not just an X server, but also an NFS package. That's the network file system, a file sharing protocol used by Unix systems since time immemorial. And NFS compatibility would have been a pretty big deal at this point in time. So getting that along with an X server is already pretty cool. But on top of this, the uploader actually included the license info. Now, I still didn't expect it to actually work. I figured it would need a security dongle or something, but I downloaded the ISO, loaded it up in a VM, and was immediately treated to the best logo I've ever seen. That's my boy. I love him. We're friends. But then, to my astonishment, it accepted the CD key and started installing. And to my greater astonishment, I then noticed it was installing a lot of other software that wasn't mentioned on the box. By the time it was done, my start menu had expanded to the tune of about 60 icons spread across a whole grip of folders. We've got Chameleon Desktop Management, Chameleon Email and Messaging, Chameleon File and Print, Chameleon Group Collaboration, Host Access, Internet Access, TCP/IP, and Xoftware. It's an absolute smorgasbord of applications, mostly just vaguely sharing the theme of being network-based in some way, but this was the style of the time. You see, this product came out in 1996 when Netmanage was plummeting out of their heyday, but they'd come up in the world during the early 90s when PC networking was different. Windows, not to mention DOS, didn't include any intrinsic network support, not until Windows 95. Well, unless you count Windows for workgroups, which few do. So if you wanted to put a PC on a LAN in, say, 93, you had to buy an IP stack. Like in a box. You had to buy your networking in a box. The most well-known product was probably Trumpet Winsock, a shareware program that famously millions of people used without the developer seeing a dime, but even that didn't come with any apps or utilities. You had to get them all from someone else. So if we go back to Netmanage's ad, the most space is actually given over to a collection of network software, just all kinds of networky type programs. They range from complex tools like a Telnet client and a Usenet reader to incredibly simple things like Ping and Finger. What? Is that not a perfectly normal name for a program? Unix machines had included software like this for years, but on Windows, you had to buy it all piecemeal, and that created a market for someone to sell you the whole kit and caboodle along with an IP stack. And as it turns out, that's actually what Chameleon was. The X server is properly called Xoftware, and the NFS server is just Netmanage NFS, but the rest of this, the dozens of other programs, those are collectively called Chameleon. And having seen how much software is here, it may not shock you to learn that it wasn't cheap. Going off this ad, the package had originally cost around $700, but by March 95, with Windows 95 on the horizon, I think Netmanage wisely saw the need to mark it down to just $200. Adjusting for inflation, though, that's a discount from $1,400 to just $420. That's the weed number. The idea of paying over $1,000 to get ping and telnet seems ludicrous by modern standards, but it made perfect sense up until Microsoft built these things into the OS. Wonder if anything like that ever happened again with that particular company. Anyway, Windows 95 didn't immediately put Netmanage out of business, partly because an awful lot of folks didn't upgrade. A lot of machines couldn't run 95, plus it cost money, but certainly its existence cramped their style. Most power users who were likely to be getting online certainly did upgrade, so I think by 96, when Chameleon NFS/X came out, a lot of the more basic tools were no longer relevant. But compared to Unix, Windows still lacked a lot of pack-in software, like Usenet and mail clients. So I think the general theme of this product is to fill in the gaps for a person or company that's transitioning from Unix to Windows. And when I initially planned this video, I'd intended to cover all this software, but I discovered that it's mostly just kind of fiddly, outdated versions of things we now take for granted. It's kind of interesting, but the X server, on the other hand, that's something most of us won't be familiar with, and it turns out that explaining its quirks leads to a lot of other interesting details about this era in computing. So I decided to stick to that subject. This video is half about a Windows X server and half about obscure bits and pieces of the X ecosystem that I think most people aren't aware of, and I think that'll be dense enough. Maybe I'll review all the other stuff in a Patreon video or something, I don't know. But trust me, you're not missing that much, and there's plenty to discuss here anyway, so let's get started. As I said, Xoftware is the name of the X server, and if we peek in that folder, that's an awful lot of icons. Which one makes it do anything? Well, obviously, X server is what we came here to see, so you'd think we'd launch that, but it's actually already running. See? It's there in the taskbar. Just has no visible window. That's to be expected, though, because this is just the X server. To see anything, we'd need some X clients, and this requires some explanation. Explanation. Since running X on Windows is a pretty weird practice, and even most Linux users these days have probably never used it as originally intended, the best way to start is to show you how a normal X server was used. And for that, we're going to need a couple different machines, which could be inconvenient if I wasn't doing all this in VMs already. So let's shove the Windows PC aside and get a couple serious computers. Here are two machines that might have existed in an office in 1996. One is a Pentium Pro server, and the other is a Pentium MMX laptop. They're both networked, so we can imagine they're connected to an Ethernet hub. Not a switch, those were still obscenely expensive, so just a hub. The laptop is running Linux, specifically Red Hat 6.1, although I thought it was 6.2 and set the host name wrong. This is also anachronistic, that's from like 1999, but man, you go any older and Linux gets really annoying to work with, so we're going to use this. The server, however, is running SCO Unixware, a genuine PC-based Unix that was very popular at the time. And this also could have been a Sun Enterprise running Solaris or a VAX 4000 with VMS, but both of those are an even bigger pain than Linux, so we'll go to war with this army. The big machine also could have been headless. In those days, they often were, but this one has a monitor and a graphics card. If we turn them on, though, we find that both have booted in plain text mode. This was also a universal thing. Unix and Linux rarely assumed you had working graphics at the time, and they were usually right, so even once we log in, we're still just looking at text. Both machines do have X installed, it just won't start until we ask it to. Now, there's a few different ways to do that, so let's focus in on the laptop here and try just firing up the X server, which at this point in time was just called X. Okay, there we go. Just like that, we have graphics, right? Right? Sir? Okay, so we do have graphics in that something's in charge of the video card and there's a mouse cursor moving around, but nothing else has happened because this is all X is. It's just a blank desktop and a mouse cursor. Everything we think of as the environment, like icons and program launchers, has to come from other programs. So let's do this over. But instead of just X, I'm going to type startx. That's a script that launches the server plus a few additional programs. So X starts up again, we get the gray background, then we get a desktop and a launcher and a taskbar and icons and all kinds of crap. Now this is a proper GUI, but none of it's part of X. In fact, it isn't even one program. Almost everything you can see comes from a separate application. One draws the desktop, one draws the taskbar, and so on. The result is a cohesive experience, but each of these programs are actually sending commands to the X server over separate network connections, and they all happen to be running on this computer, but they could just as easily be on another one and it would all still work. So let's see that. Now that I have a desktop, I can go start a terminal. And from there, I can set up a telnet connection to the Unix server. If you don't remember telnet, it's kind of like bareback SSH. Anyway, I'm in now, and if I set the display variable to the IP address of the laptop, and then I type nohup xterm ampersand, I'll explain that when you're older, another terminal shows up on the laptop, and I can interact with both of them. But if we check the greeting message, one says Red Hat, one says SCO. These are definitely running on two different computers. So this is pretty neat, but not too useful. I mean, I already had a remote terminal session over Telnet. Now it's just in another window. But we can run anything this way. So suppose I want to read my mail, all right? Unix had a local mail system you could use independent of SMTP and POP, and maybe my company still uses that for internal messaging. So I can fire up SCO mail, and that'll let me read and send messages. That's pretty neat, but let's get spicier. Suppose our company bought a copy of WordPerfect 6 for Unix. Yes, that was a product and not a cheap one. In fact, we bought 50 licenses and then the whole office converted to Linux and there's no Linux version. So we're screwed, right? Well, good news. We can run it from here. And since the program is actually executing on the Unix machine, it'll work perfect. Now, while all this is going on, if we peek over at the server, it doesn't see any of it. I mean, it's not even running X right now. And even if we start X, we wind up on a completely fresh desktop. WordPerfect, SCO mail, Xterm, all that crap is running, but the interfaces are being sent to the laptop, so they don't show up here. Also, as you can see, SCO's X experience is completely different. Instead of Linux's default GNOME environment, this is running a thing called x.desktop that was all the rage in Unix for like a year or two, but it never showed up on Linux at all. These two OSs are from different eras and they shipped with totally different configurations, but they're perfectly happy to coexist, thanks to X. There's more tricks I could show you, and some I will later, but at this point you get the idea. This is the magic of X Windows, and it's pretty amazing, although it can also be a little confusing, and I should probably explain the server and client thing before we wrap up and move on. The way we tend to think about network computing is that the client is us, the person sitting at the little desktop PC, and the server is always the big computer somewhere else with a bunch of services that we want. This is usually accurate. A server is by definition a single machine that offers services to many others. So as a user, you tend to think that when you log on to another machine and ask it to do something for you, that you're the client in that relationship. But from a network perspective, it's the other way around here, because X offers a service, a display you can put a window on. And there's no limit to how many things can take advantage of that. Connections from many sources all terminating at one destination definitionally makes X a server, and everything running on it a client. The fact that this is backwards, according to pretty much every user in history, has never been a problem for X, so to this day, it's still described in these terms. An X client is a program that you see on your screen. So, with that out of the way, now you understand basically what X was and how it was typically used. That means you're ready to see a perversion of the natural order. So let's get back to Windows. And let me start right out by saying that nothing stops you from using Xoftware exactly the same way. It even included a Telnet client, so let's try that. This time around, we're going to Telnet straight to the Linux laptop since I've made my point about the cross-platform thing, and Linux is much easier to work with. So we log in, we type the display export command, we run Xterm, and just like that, it shows up as if it were another app on the same machine. We're using Windows's window manager, if you will. So we get the typical borders. Those are created by the OS, but it's pretty clear that everything inside of them is coming from Linux, given the crusty 1980s Athena widget scroll bar. Now I'm going to get into a lot of nuts and bolts of how all this works, but first we should probably finish establishing that it does, so let's not stop at a terminal. Next up, let's fire up some productivity software. We'll start with Numeric, GNOME's spreadsheet app, then KCalc. We'll also fire up KReversi, Netscape, XMMS, and the new image manipulation program, just for good measure. And with all this crap running, let's use KSnapshot to get a screen grab. We'll save that, we'll open it in the GNU image manipulation program, and there we go. This should give you an idea of how complete this server is. Not only can it run a whole swath of common late 90s Linux software, but when you take a screenshot, it actually captures the real screen. There was definitely another universe where we only would have seen the Linux apps. So I figure at this point I've made my point. But if you still aren't convinced, that's fine. Let's just close all this crap and do the usual thing. I actually hate using Doom to demonstrate anything, but it was the only game I could think of that had been ported by this point. Of course, anyone familiar with the story of Linux Doom will already know that it has no sound drivers, but don't worry, I'm an old hand at Doom, I'll just add the sound in post.
Let's rock. Damn, those alien bastards are gonna pay for shooting up my ride.
So this is interesting because I actually compiled this from the original source code released by id Software's Dave Taylor. Other than fixing a typo he left in, this is completely unmodified, yet it runs over the network like, okay, not $1 million, but certainly a few dozen, okay? So Xoftware is definitely doing something right. You might be wondering why the Windows desktop looks so awful, and that's a thing I'll explain later, but in short, it's not a bug, it's intended behavior. It's obvious then that Xoftware is working perfectly, so how come we couldn't see anything when we first started it? Well, that's because it's running in a special mode, sometimes called rootless, as opposed to normal X, which is usually root full. That is to say, when you start X on Linux, for instance, it always creates a root window. That's what we saw when we fired it up earlier with the black and white pattern. The root window is the one thing an X server makes on its own. It has to, actually, because it usually is the whole graphics system on a machine. So if there was nothing on the screen at a given point, you'd have chaos. So the root window fills in all the empty space, and then everything you open after that becomes a child object inside of it. In fact, if you have a desktop wallpaper, that's usually just a window set to the same size as the screen and forced to always be on the bottom of the stack. But the root window is always there behind it, watching, waiting. By the way, a little detail I learned while writing this, the texture it shows by default looks like a simple checkerboard, but it's actually a cute little dog bone pattern called the root weave. I learned that from a really cool blog post from a fellow who tried to figure out who invented it. He didn't succeed, but still, it's a great post. You should read it sometime. Anyway, on Windows, the X server doesn't control the whole screen. It runs inside Microsoft's own display server, which already has a root called the desktop window. So it really doesn't need another, and if you displayed one, it would kind of cover up everything else. So by default, there is no root window, at least not one you can see, and the only things that show up are the X clients. So naturally, we don't see anything until we launch an app, but once we do, we get a very normal looking window, and it would be really funny after all that lead up if I now said, and with that, we're done. But I actually could if we were all the right audience, because if this is how you want to use your machine, well, we really are finished. Out of the box, Xoftware just accepts any connection it receives. So if you telnet into other machines and launch your apps like a normal Linux user, you're good to go. The trouble is, if you were using this, you probably weren't a Linux user. You remember earlier I mentioned that Costco still uses AS400 apps? That doesn't mean any of their employees understand AS400 systems. They just see one program which they're specifically trained on. The underlying machine is a mystery. And many businesses take this a lot further. There's actually a whole industry building web interfaces around ancient mainframe apps so they don't have to be updated. In fact, if you're ever on like a government website and you notice that everything's in uppercase, congratulations, you're probably talking to an application written in the 80s. But that doesn't really matter because you don't know it's happening. All the inconveniences have been papered over by modern code, so you don't need to know how that old software works. Likewise, a company that bought this X server wasn't necessarily a Unix shop. They might just have a few programs that they couldn't get ported, maybe because the original developer was long dead. The goal here would have been to let Bob in accounting run those apps while keeping him from ever realizing that they weren't native Windows programs running on his PC. Because trust me, Bob wouldn't know what to do with that information. He'd probably start freaking out. Plus, it's just a pain in the ass to launch everything via Telnet, so it was worth avoiding if you could, and to this end, we'll fire up the Xoftware control panel. As you'd expect, this lets us set some global server settings. We'll get into those later, but it also lets us configure app launchers, and those are very important. I have a few defined here, and if I just double-click Gnome Stones, this little status dialog opens, it connects, launches the app, and there it is. Now I can play a rousing game of definitely not Boulder Dash. No Linuxing required. This is a huge improvement over typing commands into Telnet, but it goes a step further. If we go to the Start menu and look in the Xoftware folder, there's icons here for each of my apps, and I can launch them from here, or I can drag them to the desktop where I get perfectly ordinary icons. So you can launch a remote app on a totally different OS without even having to open the control panel. This is perfect. Bob's never going to figure out what's really happening under the hood, but we want to, so let's go back to the control panel. Taking a look at one of these launchers, it's pretty straightforward. We have a host address, a set of creds, a command to run, and an interface protocol. Because, as you probably guessed, there was always a telnet behind the curtain. It can actually be telnet, rlogin, rshell, or rexec, but who's counting? These are all ways to do the same thing we just did. Log into another machine and type in the command you want. And that command could be anything you want, any valid X app, but you'll notice that it's wrapped here in those two magic symbols from earlier, no-hup and the ampersand. The first one is a Linux utility, no hangup, that keeps programs from exiting when their parent terminal session ends. And the second one makes the program start in the background instead of taking control of the terminal. The combination of the two basically tells the remote system, hey, start this program, then throw it over a fence and forget you ever saw it. Now, if we want to see this in action, we can check Show Response window. Then if we hit the test button, it'll show us the telnet session as it progresses. And you'll notice that it's literally waiting to see the words username and password come across and then sending the responses to each one as if I typed them in by hand. This is an ancient Unix tradition called a chat script. It was once used by millions to log in to dial-up internet providers, but you can use it to automate any kind of remote operation. In fact, this is how about 3/4 of a typical ISP network is maintained and configured to this day. Naturally, though, it's kind of janky. For one thing, not every system uses exactly the same text strings, so you might need to adjust your script to look for the word login instead of username and that sort of thing. But once it's set up, it's usually a pretty reliable solution, which is good because it's how most ISP networks are maintained and configured to this day. Anyway, though, as a network admin, this product passes the Bob requirements, okay? You would go in and build these launchers on each of your users' PCs, and then they would just come in and see some programs they can run. And that's the end of it, right? Assuming, of course, your network is perfectly secure. If you have any security concerns whatsoever, however, this is a flaming dumpster fire. Like, clearly my password for the Unix system is being saved in the launcher, so anyone who can access this PC can run these programs or just slurp out the file containing the saved passwords and read them. I mean, they are encrypted, but we can assume not very well. And breaking into a Windows 98 machine consists mostly of pressing escape on the login screen. So yeah, we shouldn't save the password. We should make the user punch it in on demand. And fortunately, we can do that either once a day or every time you launch an app, depending on how paranoid you are. And that's mostly it. The only other thing you can do is pick a custom icon for each app. That is important for that seamless look, but otherwise, this is a simple feature. It's a crucial one, though, because you can't train Bob Accounting to use Telnet. Trust me, I've tried. To be clear, though, this isn't a unique feature. Every Windows X server offered something like this because if it didn't, the product would be basically useless. Bob proofing was essential. And on that subject, I couldn't find anywhere else in the script to fit this in. So let's talk about the NFS component for just a moment. It's really tough to entirely isolate Bob from the reality of distributed computing because of the storage situation. See, if I open up Notepad, write some crap, and save that to my documents, then I go fire up kwrite and go to the file open dialog. There's no way to get to that file because what we're seeing here is the hard drive on the Linux machine. It has no way to see Bob's documents on his local hard drive. This is just a universal problem with X. Doesn't have a solution for it. They never planned for there to be a solution for it. This is just life in network computing. But because I installed Netmanage NFS, Windows has the ability to mount a Unix file system as if it were a Windows network share. So Bob may not be able to access my documents from his Linux apps, but if you can convince him to save his files to the G drive, which maps to his home directory on the Linux machine, it pretty much solves the problem. Now, in practice, most enterprises with domain file servers do manage to get their staff to play ball, and the same should work here. So the NFS component is really important for stitching all this together into an experience that won't scare off Bob. But let's suppose for a moment that you aren't a Bob, because there are several more interesting ways to use Xoftware. If we go up and take a look at the option buttons here, we have display, keyboard, mouse, and XDM. Obviously quite a lot going on. So let's take the easy stuff first. Mouse is very simple. That's just the option for 3-button emulation. But this is a feature that pervades pretty much everything Unixy on the PC. Let me explain this actually. Graphical workstations had 3-button mice since almost the beginning. Not quite. The Xerox Star only had 2 for some reason. Its predecessor, the Alto, had 3. And pretty much every other workstation that came after it had 3. If you had a Sun in 1982, you definitely had a 3-button mouse. So a lot of software that started life on that platform assumed this. The first PC mice, however, were 2-button. And while a third did appear, it wasn't reliable. It didn't stick. So most software never did anything with it because you couldn't assume the user had one. And sure enough, it disappeared sometime in the 90s and didn't really come back until the wheel mouse came along. And then I think a lot of users never actually understood that they could click on the wheel. So anyway, when this X package came out, most PC users only had 2 buttons to work with. To that end, 3-button emulation appeared not only in Windows X servers, but standard Linux ones as well. And it's a very simple feature. It takes longer to explain the history than how it works. To hit the 3rd button, you just press both other buttons at once. Simple as that, but if you didn't have it, you'd be pretty screwed. Now, the keyboard options are a bit more involved. Okay, a lot more. The initial dialog is simple enough. That just lets you decide if a couple special keys will get passed through to X clients or handled by Windows. But if we hit the edit button here, yeah, now we're cooking. This might be a bit of an understatement, but workstations often had weird keyboards. On some, this was as simple as having a meta key between Control and Alt, which didn't map to anything on PCs until the Windows key appeared. But other things were stranger. VAX machines, for instance, had F keys up to 20, and Suns had a bank of 11 unique keys down the left side, including stuff like stop and front. Naturally, some of these were required by certain apps, so you needed a way to trigger them from a PC, and the solution was the ability to map keys or key combos to these unique vendor functions. And that didn't eat up nearly as much time as I'd hoped, so now we got to get into the spicier stuff. So let's take a look at the display settings. So we have multi-window and single-window modes. For the moment, let's stick with multi-window, which we've been using so far, and look at this bank of checkboxes here. This is a lot of stuff. All these settings, though, are tweaks to solve the same problem, and that is, if an X app decides to open itself off screen, how do we deal with that? Now, this seems like a petty thing to have 4 whole checkboxes for, but this actually would have been a common occurrence. You see, there's 2 separate problems here, really. One is that nothing prevents X apps from launching off screen. X actually offered no guidance on where a window should appear when created. It's up to the program to figure that out, and some just didn't, relying on the window manager to handle it instead, which it usually did. If you were running TWM back in '89, creating a new window just gave you an outline which you had to position yourself. That was considered advanced. Some window managers just assumed the app took care of it on its own. There were also programs that remembered where they'd last launched, so if you changed screen resolutions, an app might put itself way off in the boonies. So we have Cascade Windows. This is a crowbar solution that makes sure every app you launch starts in a generic default position. Force window on screen only does this if need be, and fit on screen resizes any sizable window if it would otherwise not fit. If all else fails, though, we have mouse panning, a sort of emergency fallback, and let me show you how that works. I'm going to launch Xpaint here. That's a truly ancient image editor, which was first released in 1989, and you can definitely tell that from the UI. The buttons and menus are made with the X-Athena Widgets toolkit, also known as XAW, and those were the original basic controls invented at MIT back in the mid-80s. They aren't bad, they just tell us the app is prehistoric. So we'll make a new canvas with the default resolution, and when it appears, it very much doesn't fit on the screen. Failing to take a lesson from Photoshop, which hadn't been commercially released yet, Xpaint has the color palette anchored to the canvas window. My screen res is only 800 by 600, so with the default 640 by 480 canvas, the window doesn't fit. Now, if this window couldn't be made smaller, we'd be in trouble. If we just mouse to the edge, though, Xoftware scrolls the window into view, more or less solving the problem. It's a clunky solution, but I can't think of any better ones, and this'll get you out of a bind. Let's address, though, why that bind existed in the first place. Xpaint's window can be resized, and it does have scroll bars, so it can be made to fit on this desktop, but I picked it as an example because I think it reflects how a lot of Unix software was designed. This app is pretty chunky. Its default settings and general UI geometry seem to expect at least a 1024 by 768 display, yet I said it hailed from 1989, so isn't this a bit anachronistic? Well, here's the thing. Most workstation computers had never seen a resolution that low. The Xerox Star kicked off commercial graphical computing at a crisp 1024 by 808 way back in 1981. Most Unix systems supported much higher resolutions than that, and I'm not aware of anything that went lower unless you want to count weird low-cost one-offs like the AT&T Unix PC or the IBM RT, and I don't think anyone does. Also, while the PC was stuck at lower resolutions throughout the 80s, by the time this software came out, that hadn't been the case for a long time. By 1992, nobody was selling a PC with a display smaller than 1024. It was the lowest common denominator, and higher resolutions have been possible for years if you spend a little money. Trouble is, many PC users chose to run at lower resolutions for two reasons. One is because video memory was still pretty expensive, so while you could definitely run at 1024, you'd be limited in most cases to 256 colors. If you had a really high-end card, maybe you could do 16-bit, but usually you were stuck at 800 by 600 if you wanted the higher color depth. But also, lower resolutions often just looked better. While Unix machines came with fantastically expensive 15 and 17 and even 19-inch displays, PC monitors in the mid-90s were frequently still 14 inches unless you really shelled out, and 1024 at 14 inches is pretty tough to read, even before you figure in the god-awful shadow mask tubes typical of the era. So a lot of people used lower resolutions just because they were more legible. Now, Linux was an exclusively PC phenomenon for its first couple years, so a lot of its software was designed to work at those lower sizes. But not all of it. If we fire up K-Snake, for instance, that's one of the games packed in with the KDE desktop, and despite shipping in 1999, when PC monitors still frequently sucked, this can't be made small enough to use at 800 by 600. It just doesn't work. And that's simply an oversight by the developer. I imagine he had a 1024 by 768 display and just never got around to testing with anything smaller, or even really thought about it. I mean, a lot of software that came with Linux distros in this era was literally people's unfinished student projects that hadn't been thoroughly tested because they didn't really imagine anyone ever seeing them. And this isn't really that big a problem. I mean, K-Snake isn't a particularly crucial app, and I imagine most Vital software was a bit less naive, but programs that originated on Unix were far more likely to expect the user to have a big display, even major commercial apps that had been thoroughly tested. So I think it's very likely that the mouse scrolling feature made a lot of unusable software usable. If all else failed, though, there was always single window mode. I'm sure you've been wondering what that does, so let me flip the switch here. It restarts the server, and what do we get but a root window, complete with that fashionable weave that's all the rage these days. While you don't need a root window, and most people wouldn't have wanted one, there are reasons to use it anyway. The simplest is that you might want to shove your whole Linux environment aside as a whole, and let me show you what I mean by that. If I'm in multi-window mode and I launch Xterm, then Xeyes, then another Xeyes, notice that we're stacking up taskbar buttons here. On a low-res display, running more than like 6 programs starts getting really unwieldy, and this is really bad if you launch a program that has a bunch of sub-windows, since each one will get its own button. And if we do the same thing in single window mode, however, everything appears inside the root window with just one taskbar icon, so we can minimize it all at once. You'll also notice there's scroll bars now. We can actually scroll the desktop around. Now, by default, Xoftware creates an X session at the native Windows resolution, so, well, we only have a little bit of scrolling here, but in the settings, we can choose a virtual screen of any size we like. So we could set this to 1280 by 1024, then open a ton of apps, and we'd still be able to scroll around inside the virtual viewport to access everything. And this was actually a common feature even on native Linux X servers back in the day. So that's all neat, but we have kind of a problem now because there's no way to minimize these apps or move them or even close them. They're all just stacked up in one spot with no borders or controls, and this is because running in single window mode makes Xoftware act like a conventional X server. As far as it's concerned, this window is your monitor, and all the clients are inside of that where Windows can't see them, so it can't draw borders and controls. To fix that, we have to do the same thing we did on Linux. We have to launch a window manager. So let me do that. This will take a little while to start, but there we go. Now we have a complete usable environment with borders and controls and more, although we'll get to that. First, though, I feel like addressing this command that I typed, it's kind of wrong. It's actually running a desktop environment called FVWM, which was very popular in its day, but for some reason, Red Hat aliased it to MWM, which is short for Motif Window Manager. And Motif was a really big deal, which I've learned a lot about recently, so I'm just going to take this opportunity to arbitrarily go on a tangent about it. It has very little to do with Netmanage Xoftware, but you're not going anywhere, so let's go for it. You may recognize Motif as the classic Unix look, and this is true to a point. I mean, for many years, this is what everything looked like, whether it was AIX, IRIX, Solaris, you name it. But Motif actually came to the game fairly late. Prior to 1988, Unix systems all ran totally different GUIs. Sun had OpenLook, SGI had MEX, HP had Windows 9000. Yes, it was really called that. Made Microsoft look real bad. Even by 99, they could only manage Windows 2000. But speaking of Windows, I wonder if you've noticed that Motif looks curiously similar to early versions of Windows. Probably not, because most people have only seen Windows 3, and it really doesn't look all that similar. But check this out. This is Windows 2, and it looks nearly identical. It has the segmented borders and the horizontal stroke and the close button. It's very obviously the same interface, just at lower color depth. So, was Microsoft ripping off Unix to make themselves look more serious? No, of course not. I wouldn't even have brought that up. Okay, Motif was actually the result of a fascinating process where all the workstation vendors, Unix or otherwise, got together and agreed on a single common interface style. This would make training, porting, and development less of a hassle since there'd actually be a central guiding ethos behind their UI. Imagine that. Now, that common interface was named Motif, but it wasn't created from scratch for this purpose. Instead, when this Council of Nicaea formed in '88, they put out an RFP, basically saying, hey, does anyone already have a good solution for this? And they took offers from a whole bunch of vendors. But the winner was HP's CXI design, which they were about to adopt in their own Unix variant. But even that was based on another thing called the Common User Access Guidelines, or CUA, which in turn had come from IBM. Now, IBM was selling their own Unix variant at the time, so this doesn't seem like that much of a shocker, but I'm not sure they'd actually shipped CUA in their Unix yet, nor am I convinced that they developed it for Unix to begin with. I think they actually put it together for OS 2, which, when first released, looked almost exactly like Windows 2. This is because Microsoft was collaborating with them on OS 2 development, and they planned on giving both operating systems the same UI. The thing is, though, OS 2 was a rolling disaster, so Windows actually beat it to market by like half a year and came out in mid-1987, which I think makes it the first appearance of the classic Unix look. Now, I admit I feel a little shaky on some of these dates, but since I find this version of the story extremely funny, I'll leave it to someone else to figure out the actual timeline. Anyway, as I said, this isn't just Motif, it's FVWM, which bundles a Motif-styled window manager along with a desktop environment offering a little task switcher, a virtual desktop widget, a mail status icon, and a clock. And as you can see, it also dresses up the root window with a background. This is important because while the Windows taskbar and start menu approach wouldn't take over in the Linux world for a while, people still wanted a way to manage and launch apps. And in classic Linux style, FVWM does this through incredibly opaque methods. Right-clicking on the desktop gives you a list of running programs, middle-clicking gets a list of window management tools, and left-click produces a list of apps you can launch. This is all incredibly convenient because, you see, if you're using Xoftware to just run one or two programs, if you're Bob in accounting, then building launcher shortcuts for everything is workable. But if you're using a remote machine in a more full contact fashion, running all kinds of different apps and using each one heavily, it might make more sense to use this mode where you get something more like a Windows Remote Desktop style experience. The whole Linux system lives in a window and you can use it as if you're sitting directly at the local console. If you're going to do that, you're going to need a full desktop environment. Although, if that is what you're doing, you might want to just use the X feature that's actually intended for it. And this brings us to XDM. That's the X Display Manager, and very few people are familiar with it directly nowadays, but its derivatives like GDM, KDM, LXDM, and SDDM are ubiquitous, and they play a huge role in making Linux look less dated. See, all Unix-like OSs are intrinsically text-based, and this will never change, but a modern Linux PC never shows text for even a moment during boot. This is thanks to a complex relay race where the video baton is passed from kernel mode VISA drivers to one of those various DMs. So you get a nice logo during boot, and then after boot, you get a nice graphical login prompt. That comes from KDM, GDM, etc. Now, the graphical boot part, that didn't exist till the 2000s, but as far back as '88, you could configure your PC to give you a graphical login. The thing is, though, this is only part of XDM's purpose. For a moment, let's go back again to the early days of terminals. In 1987, if you weren't working with graphical apps, you might have bought an IBM 3270, a Weiss 60, or a VT220 to hook up to your mainframe. To be clear, though, while people often refer to those as dumb terminals, they were whole computers. They were just very, very basic ones. Even the ancient VT100, the classic example of a dumb terminal, had an Intel 8080 CPU that could have run any program under the sun. It was just stuck with 3K of RAM and no floppy drive, so you could only run the one program that was burned into its ROM chips. That did make it far more affordable than a general-purpose computer, though, so it made sense. And the same concept was tried in the graphical market. Obviously, X Windows requires a pretty hefty computer to function at all, but efforts were made to produce cheap ones. In the late 80s and early 90s, a number of companies put out dedicated X terminals, which were basically cost-reduced versions of desktop workstations with very little RAM and no local storage, which were designed to run just one program. You can guess which one. I actually own one of these, a DEC VXT2000, and its firmware and storage are so limited that it can't do anything on its own. It relies on a network boot server to send it an X server package every time it starts up, which it then runs entirely from memory. Now, it does have a Telnet client built in, so you could use it to connect to another machine and launch some apps, but early X terminals didn't, so they needed a way to find a system willing to host an X session for them without any tools. XDM provides for this. An X terminal can use the XDMCP protocol to search for other systems on the network, ask if they're willing to host, get a graphical login prompt, and fire up a session, all in a nice, clean graphical workflow. So it was extremely important for making X terminals feasible, but since it was all part of X itself, you could take advantage of it even if you were on a full-fat workstation. So Let's see that in action. I'm going to go into the XDM settings here, and you'll see we have several options: direct, indirect, and broadcast. The first one's real simple. If we pick that, it wants a host address, so I put in the laptop, hit OK. The server restarts, and we get a login prompt from the Linux machine. If I log in, I get a complete desktop environment exactly like I did on the machine itself. So earlier I showed you one practical approach to Xifying your Windows machines, but here's a totally different one. Suppose you don't want to pretend your remote apps are actually running on Windows. Instead, you want your users to know very firmly whether they're working with a remote system or not. Well, just configure Xoftware on all their machines to connect to an assigned host like this, and now you have a nice, bright dividing line. And I should also point out that since we're in single window mode, this all lives inside the Xoftware root, and so we get that sort of remote desktop / VNC style experience. But this is actually optional. If you want, you can run this in multi-window mode, and it works surprisingly well. Some of the components, like the GNOME taskbar, don't integrate with the Windows desktop all that well, but I imagine you can tweak a lot of that to make it work better if you know what you're doing. And at this point, if you're even attempting to operate this way, you probably did. Let's go back a step, though, and assume we aren't so savvy, and maybe we don't actually know which host we want to connect to. Maybe we're a guest at a university campus. Or maybe we do work here, but we need to jump back and forth between hosts over the course of the day, and we don't want to memorize all their host names. In any case, there's options. For instance, if we select broadcast, that'll blast a message out to the whole network asking for open hosts. Anything that responds appears in the list, and I can just pick a machine to connect to. This is the SCO Unix system, for instance. If I pick that, I get the extremely dope SCO login prompt, and if I log in, I actually get that whole wacky x.desktop environment. So this works, but there are a number of issues. For one thing, it's not very secure, since you can't control which hosts appear. But also, if you have a huge network, a user might see a massive list of names and get bewildered. And finally, if your network contains multiple routed subnets, you can't broadcast to all of them. It's just a limitation of IP. To solve all these problems, there's XDM indirect mode. This allows you to nominate a host on your network as a chooser, sort of like a master browser in Windows networking, a machine whose job is to know what other machines are available, and there's actually a ton of flexibility built into this feature. If I go to indirect mode and pick one of our hosts, then restart the X server, I get this incredibly grody list view. It's not a complaint, mind you. I love the Athena look, but man, get a load of those serif fonts. Anyway, this looks like a dressed up version of the broadcast setting, but there's actually a lot more going on. This list is handcrafted. There are other machines on my network, but I've told XDM that for this host, these are the only ones that should appear. And this can be tailored any way you like. This computer could get a totally different list than another one, and matches can even be made using subdomains. So you could give one list of hosts to star.accounting.company.com, and a totally different one to star.engineering.company.com. Obviously, this is a far more precise and slightly more secure solution. In any case, though, once you have the list, you just double-click a host to jump into a session, and that's all there is to it. So with that last trick, we're pretty much at the end of the tour, so now we got to mop up. Like I said earlier, half the purpose of this video was just to talk about X Windows itself, but insofar as it's also a review, I guess I'd have to say that I think Xoftware is a great product. It's easy to use, and it's pretty lean, yet it has pretty much every function I can imagine wanting. Okay, actually, there are a few things I wish it had. For instance, I think it'd be great if you could run multiple servers side by side, so you could have distinct sessions on multiple remote machines at once and easily tell them apart. But I've never seen anything that supported that, so I can't criticize it too hard. Likewise, I wish it had color space conversion, but nothing ever did that for some reason. That requires some explanation, though, so I finally get to tell you why Doom made the desktop look weird earlier. Okay, so up through the mid-90s, the highest color depth you could expect on a PC, and even on many workstations, was 8-bit or 256 colors. Doom was written for this mode, as was a lot of Linux and Unix and even Windows software, but the Linux Unix stuff was picky in a way Windows apps usually weren't. My Windows desktop is currently in 16-bit color mode, and if I attempt to run Xfishtank, I get told that it only supports 8-bit displays. But if I go in and set my desktop to 256 colors, then try again, it works. And you think to yourself, what's going on here? 16-bit is way more colors than 8, so what's the beef? Well, the beef is that these two modes work totally differently under the hood. 8-bit color is palletized, meaning that colors are represented by arbitrary numbers defined in a table. Every pixel in an image contains a value from 0 to 255, and when it's displayed, it has to be looked up and converted to real colors by your graphics card. Higher color depths, however, represent pixels as raw, literal red, green, and blue values. Now, you can convert between these formats, and it's not even particularly hard. Windows 95, generally speaking, is happy to do it, but for some reason, almost no X server will. I have no idea why. To run a 256 color app, you're just required to exit the server and restart it in 8-bit mode. Now, I suspect this limitation made sense and was unavoidable in, say, 1992. I also think it was completely avoidable by 96, so Xoftware could have dealt with it. But again, it's tough to judge them for not doing better than real X. The done thing was to just throw an error and die, and I don't get the why of it, but it was what it was. With all that said, however, Xoftware does do something unusual compared to most servers. When I first launched Doom after compiling it, it actually looked like this. Now, obviously, that's not right. The game is pretty unplayable, but you'll notice that the rest of Windows still looks normal. These are related facts. This is all due to a Xoftware setting called Reserve System Colors. You see, in 8-bit mode, the color palette is global. All apps have to share the same one. If a program decides to redefine color 6, then every program that uses color 6 will be affected. The result is what we saw earlier. The desktop turns gray because Doom uses that palette entry for a stone texture or something, and when you pick up an item or get shot, the entire desktop changes colors because the palette is being switched out repeatedly to create the yellow or red flash effects. If we click out of the Doom window, though, everything goes back to normal. But now Doom is trashed, and this is again intended behavior. On normal Linux X, when running in 8-bit mode, every time you click to focus on a window, the app will load its custom palette. So if you're running anything that deals in complex images, chances are your whole display is going to radically change every time you switch apps. And this sucks, but Windows actually had the exact same problem and solved it the same way. You just usually didn't notice it because they put in a little extra effort to make the UI more consistent. Windows defines a set of 20 system colors that apps aren't supposed to change. They can, but most didn't out of courtesy. And since those colors were used for 99% of the interface in most apps, you usually wouldn't see any wild color changes. The exception was if you loaded up a full screen game. Those did redefine the entire palette, which resulted in a flash of hideous colors every time you alt-tabbed in or out, but that was obviously a minor problem that really couldn't have been avoided. X, however, didn't have this concept of reserved colors at all, so by default, Xoftware imposes it. It doesn't allow X clients to override those 20 reserved colors, and while this would obviously corrupt the occasional window, and you'd have to go turn the setting off, much as I did for Doom, it probably delivered the most consistent default experience, so I think they made the right choice. And in general, I think that Xoftware makes the right choices, even if there are some things that could be done slightly better or be a little more configurable. The fact is, though, an X server isn't even supposed to have a user interface. A lot of the settings we've changed would have involved editing conf files on a Linux machine, so everything I've shown you was bonus material. It's all stuff you would have welcomed, but given that you'd invariably have had a Unix expert setting it all up in the first place, it was probably fairly optional. So let's talk turkey. What's much more important than feature set is compatibility. I made a big deal out of X running on every platform under the sun, and the whole point of it being an open protocol is that every implementation can work together, but that doesn't mean there aren't quirks, and it doesn't mean a given server can't have bugs, and this one seems to. I mean, for the most part, any contemporary software I've thrown at it has worked. Although, if you're curious, non-contemporary software was less successful. I tried sending over some clients from a 2018 Ubuntu machine, and pretty much everything just crashes. I couldn't even get GNOME Calculator to work. But to my shock, Firefox actually ran. Like, a lot of the UI was broken, but the core browser actually functioned just fine, albeit really slowly. None of this shocked me, however, because while the fundamental X protocol hasn't changed over the decades, they have added extensions. Now, at one point, these were optional, and apps could even gracefully degrade if they weren't present, but I think we're way past that. There are now extensions you can't function without, and again, Xoftware couldn't really have done anything about that. On the other hand, they probably could have fixed whatever's going on with Netscape. For the most part, the browser works just fine, but something is hosed with the colors. Not only do all the icons appear in 1-bit monochrome, but all embedded images have swapped color channels. I realize Red Hat's a pretty old brand, so maybe you thought this was a gag on their part, but no, the hat is supposed to be red. And if we navigate to a real website and look at some images, they're clearly not right either. In fact, if we go down and take a look at this one, where I actually labeled the color channels on the video plug of my DEC-X terminal, you can clearly see that red and blue are swapped. This is obviously a pretty bad bug, and it would seem pretty damning, but on the other hand, I searched for this problem on Usenet, and it seems to have happened with a lot of X software at different times on different platforms. So Netmanage isn't entirely to blame, especially since this doesn't happen with any other apps. And when you're running X clients on a server they were never tested with, this is exactly the kind of problem you can expect. Stuff doesn't crash, but it produces incorrect results, and sometimes they're much subtler. For instance, you may not have noticed this, but if you look at the buttons on the Motif window borders, they're all drawn wrong. The dark lines don't meet up with the light ones, and this is present on every button, and it also happens on the quote-unquote taskbar. The lines are all hanging off on the right. Likewise, a lot of the lines in Netscape have these tails, and if we take a look at the exact same app running on a typical Linux X server, none of this stuff is happening. This is the same program exported from the same host, yet the colors are right and the buttons are rectangles instead of Photoshop crop icons. So it's definitely the server at fault. It seems like Xoftware has an off by one error in its line drawing routine, and most likely Netmanage released a patch for it, probably for the color channel issue too, but also probably only to registered customers, so they're gone forever now. Who knows though, and who knows what other bugs might be in here. X is big and complicated, and I'm not even going to try testing everything, so frankly, I just assume there's other bugs. Because open source software development at this point in time was even shakier than it is now. Almost nobody was rigorously testing anything, so making any two programs work together consisted of different teams firing off bug reports at each other, then issuing fixes that came out in separate release intervals with other changes made in the interim, so nothing ever really lined up. But this wasn't that big a problem for Linux users because it was assumed you'd be constantly downloading, compiling, and installing patches. I mean, anyone who claims that wasn't 90% of the Linux experience back then is remembering incorrectly. Netmanage, however, being a Windows-focused for-profit business, wasn't part of this communal back and forth, so I expect Xoftware was a permanent second-class product. Still, since you were most likely going to use it to run apps you bought in 1989 and last updated in 91 on a defunct Unix from a moribund vendor, I expect it all turned out okay in the wash. And hopefully the same is true for this video, but for the life of me, I can't even figure out how to wrap it up. The trouble with reviewing software, after all, is that every program is made up of 1,000 tiny features and behaviors, none particularly remarkable in themselves, so in the end, you're just staring at little dialogues and talking about mouse customizations. It's incredibly hard to make that interesting, and even harder to arrive at any conclusions. Really, though, I did my best, and hopefully it panned out. So if you did enjoy this, I'm glad to hear it. And if you're new to my channel, consider subscribing, since I can almost promise my next video will be considerably more exciting than this. Remember to turn on notifications if you want to find out when that's released, but if you really enjoyed this, then please consider supporting me on Patreon like these folks somewhere on the screen are doing. This is my full-time job, and since I'm currently recovering from minor surgery, I haven't been able to do it very well lately, and not for a while more. So now would be a great time to show your support. I have a whole studio sitting across town that I haven't been able to use for over a month, but I'm still paying rent on it. So if you want to make sure it still exists when I'm back in fighting trim, this is the way to do it. I do want to express my deepest gratitude to my existing patrons. I can't thank you enough. I don't know what would happen to me if not for your continued support. And to everyone else, thanks for watching.